We are here for the second keynote of the conference. We have invited for this Dr. Mounia Lalmas. A quick presentation of Mounia. So Mounia is a very active member of the web search and recommender systems research communities, as she has been contributing for a while, both as an author. She has authored over 260 publications, and she has volunteered to support different communities in the field by co-chairing major conferences, including this same conference, the web, CGIAR, Wisdom, and CIKM. Mounia is currently a Senior Director of Research at Spotify, where she leads tech research in personalization, focusing on search, recommendation, and discovery systems at scale. Her work spans information retrieval, recommender systems, user engagement, and the application of modern AI techniques, including generative models, to large-scale online platforms. She previously held senior roles in industry and academia, including Director of Research at Yahoo, a Professor of Information Retrieval at Queen Mary, University of London. She has also held a research professorship at the University of Glasgow. Dr. Mounia is an honorary professor at University College London and a distinguished research fellow at the University of Amsterdam. Her work bridges foundational research and real-world deployment, with the current focus on how AI is reshaping large-scale systems. In today's talk, titled Building AI-Driven Web Experience at Scale, Mounia will share insights on how recent advances in AI are reshaping the design space of web technologies. Mounia, thank you very much again for accepting our invitation. We are really pleased to have you on board with us, and we're looking forward to listening to your talk. The floor is yours. Thank you very much.
Thank you very much. Let me just share. Oops. Oh, I did it before. Share screen. Oh. Share setting. And we did it before. Should have stayed.
Okay, it takes a bit of time.
Let me just remote this. Edit. Oh. Content
That's
design.
the beauty of the online.
It worked before. So I go to share setting. Now maybe. Okay, I got it now. I was trying to be too smart. Okay.
Yes.
I think we're good to go.
We are good. Floor is yours.
Okay. Yeah, so thank you, Hakim, for the introduction. So good morning, afternoon, good evening, and thank you for joining. It's for me a real privilege to give a keynote at the web conference. So again, thank you to the organizer for the invitation. So my name is Mounia Lalmas. I lead the research team at Spotify. We work on personalization, recommendation, and evaluation. So today I want to talk about something that really sits at the intersection of what this community, the web conference, is doing research, interested, and also what we're living through in industry right now with AI. I will focus on personalization system. Those are systems that decide what users see, hear, and discover. So that will be the focus. And at the same time, I will relate concrete, discussing work that we're doing at Spotify. While it is a little bit maybe specific to the kind of application and challenge and so on, it is relevant to many other recommended systems out there. So there's going to be four parts to the talk. I will start by kind of explaining the role of personalization in the respect to the web and how AI is actually changing it. Then we will move into the bulk of the talk, focusing on this new technology that comes with AI, generative and agentic system. And I will start to discuss what we think, at least at Spotify, but also I know other people are also seeing this, how search and recommendation are converging. Hopefully, I will have time to talk about evaluation. This is also quite a passionate topic of mine. So what is happening with AI? First, we have to evaluate the system, a new system, a generative system, but also AI is providing new tools to do evaluation. And I will close with looking ahead at the kind of things that I think we should be working on and so on. So let's just start. So AI and personalization. This is really how the web connects people to content. So let's just kind of frame it a little bit by what I mean. So let's just start with this second column, which is about abundance. So the web contains far more content that anyone can navigate. For example, and just at Spotify, we have more than 100 million of track. So personalization is what makes the web navigable. It surfaces what is relevant from like a huge amount of content. Scale is a big part of this. Results of a search engine recommendation, they assemble uniquely for each person. It has to be done in milliseconds across billions of users. Every time someone opens Spotify or Google or any other platform, they're not seeing the same thing as a person next to them. The experience is constructed for them in real time, and this comes with what personalization is about. This various stakes into personalization because what gets surfaced shape how people discover culture, information, commerce, and so on. So this decision involves multiple parties: user, consumer, creator, platform, advertiser, and so on, each with different interests. For the purpose of this talk, I will focus only on the consumer part, people going to the web to do something, to consume content, and so on. So let's ground a little bit of this to really understand the scale and the challenge. Spotify, for example, have more than 700 million active users available on more than 180 markets and so on. You have music track, audiobook, podcast title, and so on. The diversity of content here is as important as the volume. Music, podcast, audiobook, this means different listening patterns, different discovery dynamics, different way users relate to them. All of this has to be personalized for every user in real time. So it's not just the big numbers, it's a type of content itself. So personalization has gone through maybe 3 broad phases. The first one is human curation. A human decide what is relevant and surface it editorially. For example, you can think of the old time of Yahoo original directory. As Spotify, this was the era of hand-picked playlist curated by editor. The second phase is predictive. A lot of the machine learning approach that we've been that's been also presented also at this conference. So model learn from behavior to predict and rank content. The system observe, record what the user listened to, what they skip, what they save, and learn to predict what the user may want next. Discover Weekly is a well-known example of Spotify, a mixtape unique to each listener, comes every Monday and is built from everything the user has listened on the Spotify platform. We are now in the third phase, which is the generative phase. So systems that understand intent and reason over it. So instead of inferring what a user might want from past behavior, those generative systems can respond to what the user expresses in the moment. Find jazz postcard for my commute. The system interprets the request and produce a response. So this shift mapped to actually a deeper conceptual change. So for most of the history of personalization, the system job was more or less to guess, using implicit signal, what the user click, what they stream, what they abandon. the system learn patterns and infer what might be relevant next. It's a powerful approach, but it's always working from what the user already has revealed from their past interaction. It cannot really respond to what user want right now expressed in language. And this is the move, the personalization toward reasoning. The system understands language, has context, can respond to stated intent. I'm on a long drive, give me something engaging. I've heard everything by this artist. What's similar but new? Those are not answerable from just historical signal alone. You need language understanding and in the moment reasoning. When you have reasoning-based personalization, 4 things become possible on the system side. Intent understanding, natural language replace keyword search. The system interpret what was meant, not just what was typed. Explainability, recommendation can come with reason, not just a ranked list. And this we can trace the decision. Agentic reasoning, the system plan, retrieve, synthesize across listening history, catalog knowledge, and context before producing a response. With respect to agentic reasoning, it's important to remember the work around agents is not new. There has been quite some work a long time ago. It is now the reasoning capability has improved considerably, and it can be done at scale. The 4th one is real-time steering. The experience can be redirected mid-conversation through natural language without starting over. And this is a big change also happening in personalization. So together, this shit also has an effect on the user side. What is happening now is interaction with personalized system. They're becoming a conversation. People can express preferences explicitly, refine results, inspect how the system model their taste, rather than simply receiving recommendation with no idea where they come. A note on this capability, again, they're not totally new, but they're working much better at scale with good quality and so on. At Spotify, we are making use of those new capabilities. Those are just 2 screenshots of what reasoning-based personalization look like in practice. On the one side, you have a conversation where user can ask for dinner party and want to refine what the result mid-conversation, for example, adding more house music. On the other side, something that is quite new, test profile. It's a feature that shows user has Spotify understand their listening preferences and give to them in natural language, so they understand, who I am, and they can actually shape it. So at Spotify, we've been building and evaluating a number of such capability, and I will focus on 3 for this presentation. Generative recommendation, where we're moving from selecting item to generating response tailored to the moment. Then agentic search, from single query retrieval to multi-turn discovery, where system reason over intent. And evaluation, where we're moving from offline metrics to method that can now assess intent satisfaction, response quality. Something that is also important, what I'm going to present is really the capability, but there's a lot more work behind it. There's a cost associated using the system, latency, there's also safety aspect that come with using those systems. I will focus for the purpose of here on the capability and how the actually algorithms are changing. So let's start with generative and agentic system. So search and recommendation are 2 ways to connect people to content. They have traditionally been treated as separate disciplines. Search operates on explicit intent, the user type a query, the system matches it to a corpus and ranks by relevance. It is user initiated and single turn. Recommendation operates on implicit preference. The system model of user taste, user profile over time, and surface what might resonate. It is mostly system initiated and continuous. Different signal, different architecture. Different research community, although to a lesser extent, being as involved in the SIGIA senior committee. There was a lot of recommended paper that was submitted at the SIGIA this year. Going back to 92, for those that are old enough to remember that time, Nick Belkin and Bruce Croft wrote in the communication of the ACM, the information retrieval, search, and filtering, kind of a basic version of recommender system, are two sides of the same coin. So the intuition was there early. Both are trying to connect people to relevant information from different directions. What has changed is that AI is now making that kind of convergence practical. It provides tools to build systems that understand natural language, can model user context, and reason about intent. When you can do all of that, the distinction between search and being recommended some content start to dissolve. And this is going to be like a theme in this part of the talk. To go a little bit more into this, so the architecture, this conversion point toward this. So on the left side, you have three modes of interaction. The user may come with an explicit query, find something specific. They may want open discovery, surprise me, or they may be in the middle of a multi-turn conversation, refining and following up across turns. The surface through which they engage differ, but the underlying need is the same, the right result, however the request was expressed. At the center sits the AI, which is, I would say, an agent, or is becoming an agent. The job of that agent, the AI, is to interpret what the user is trying to accomplish, regardless of how the request was expressed. That means reasoning about intent. Is it a lookup or an exploration? It means drawing of what we know about the user, their taste, their history, their past interaction. It means tracking down how the conversation has evolved, what was said before, what was clarified, what preferences were expressed along the way. On the right, two sources of the knowledge. The AI agent draws on platform data. In our case, everything Spotify knows about its users, the catalogs, and the world knowledge that come with large language model, the semantic understanding the LLM brings, which really allow it to reason about context, content, and meaning beyond what interaction logs alone can bring. Are we there? I think we're going there. The rest of the talk we describe step we have taken toward this. Let's go to the first one when we're moving from ranking to generating. What you see on the right side here is Spotify podcast surface today. It's not a rank list, but a generated feed that responds to what we know about the user, what is new, who the user follow. This is really what generative recommendation looks like in production. The work I will be present comes from two papers. They address related but distinct problems. The first one is about building a single model that handles recommendation, retrieval, user understanding, and more jointly. The second is about taking that foundation to production under real latency constraint for users. The premise both papers share is a conversation require one model, not separate system, whether it's for search, recommendation. So let's start with this unified generative model. So the core problem is recommendation, text retrieval, user understanding, and so on have historically, not always, but in general, lived in separate models with no shared understanding across tasks. Building a separate model for each is expensive, and we lose the benefit that one task can teach another. More fundamentally, none of those separate models can handle the full range of what we believe conversation require or will require even further. So we built a single model with 3 capabilities: generating personalized recommendation across content types. Itself could be at several capabilities: retrieving catalogs, item from natural language query, and explaining recommendation and describing user preferences. And describing user preferences. So we have one model, 3 capabilities, because one conversation cannot afford to switch. Okay, this is search, this is this, which model, and so on. For this to work, there was 3 design decisions, and they were important. First, natural language as the interface. All those capabilities are accessed through natural language that come with LLM, which really what allowed the model to be steered at inference time without retraining. Second, the foundation, we use semantic ID, not text title. So semantic ID is a short token sequence representing a catalog item. We all know LLMs, how they work is tokens together. We wanted to map this notion of token into also a bigger LLM that brings this world knowledge. There's several methods to build them. We're still experimenting, and you can read also much more from the paper, but also there's work coming from other companies, and in particular Google. So for us, these token sequence are organized in kind of coarse to fine hierarchy. In our context, because the first token is maybe about the genre, then the subgenre, something below, maybe exactly the specific item. Semantically similar item gets similar sequence. So more or less, taking it like directly, is we have vectors that represent content. 2 vectors are close to each other. If the content is related, we kind of put this into this token representation. So this means that the model generates valid catalog item directly. So take a token sequence that decode to a real item, a candidate, like an item that exists, and not hallucinating a title, which we know that LLM are quite good at that. So we have seen that item organized this way outperformed flat alternative, more or less using directly the atomic ID as part of the token. Training happened in 3 stages, and the ordering is again a deliberate design choice. In the first stage, the model learns the catalog, so mapping item to their semantic ID sequence. And we do that while preserving the language understanding that the LLM is bringing. The key constraint is we do not want to put something onto the backbone LLM that we're using. We don't want to override the power of the language competence. In the second stage, the model is aligned more with how users interact with those catalog items. So we have like behavioral pattern, preferences, and signals. And the third phase is when we actually do the multitask training, recommendation, retrieval, user understanding. They are trained jointly. By this point, the model has a stable foundation, and the tasks are there to reinforce each other, then compete with each other. Results compared to strong task-specific baselines show improvement across the board, and there is a positive cross-task transfer. Being good, for example, retrieval make also the model better at recommendation. So this is what the unified foundation gives you, and is exactly what, when we're talking about this conversation, recommendation, search, and so on, a single model can handle whatever the user asks in whatever form it takes. So that was the first part. Now let's bring this at scale. So the second paper, take that foundation, the semantic ID, and how we add it into the LLM, and incorporating various, actually the Spotify data, like user preference and so on. And we put it into production in the context of podcast recommendation. So It could be like during a conversation, a user is looking for familiar content and maybe later on want some new discovery. In those scenario, traditional recommender system trained on listening history will naturally favor what the user has already seen and consumed. Surfacing new content has traditionally required retraining with a different objective. It's expensive, it's slow, and it ends up being a model that is pretty good at one thing. So we wanted to be away from this. So we wanted really to kind of instruct the model, this is familiar content, this is discovery content, and so on. So for this, we keep the same semantic ID foundation that I described just before. So the model stay grounded in the podcast catalogs, but we add two mechanisms built specifically also for production constraints. The first is soft prompt for the user history. So rather than including the full listening history in the prompt, so where the user are, which would exceed context limit, whether this is going to remain a problem or not is to be discussed. But we kind of use this as a soft prompt, as more or less is long-term references are compressed into a dense vector, and they are prepended to the model input. The second is what we call control token. At serving time, a single token, familiar or unfamiliar, is appended to the prompt. And this is what we mean by the model is steered to a particular type of recommendation. So we have one model, two modes, no retraining required. So the platform can serve different moments in the conversation without rebuilding anything. See, I'm good for time. So the system was deployed at production scale on Spotify home surface. There was a pipeline for people working into recommendation. There's a typical pipeline. So offline training on the podcast catalog with semantic ID. Then there is a candidate generation at serving time, where the model output token sequences decoded back to the episode ID, and then the control token appended per request. More or less, is it familiar, non-familiar? A/B test results, we were able actually to increase what we call non-habitual streams, like new content, but also bringing show that maybe were not so visible to users. So we increased like new show that were actually streamed. And this respecting production cost and latency constraints. With respect to that, something to highlight, LLM are not fast, and running token sequence decoding at Spotify traffic scale requires a serious engineering work. The paper has quite a lot of this detail, and the deployment lessons actually are as important as the modeling at the model design. So the key principle here is the control token lets one model serve different moments in the conversation, familiar content when that is what is needed, new discovery when that is also is called for, and we call it like steerability in practice. Some lesson, and more or less going one level up. What does it mean? What have we learned, and so on, and what we think is next. So, respect to generative recommender system, convergence, if we're moving from something where it's going to be search recommendation, user representation, and so on, we need a shared representation. A unified model for search and recommendation and other tasks is only possible when all capability share the representation of content. We're using semantic ID for this. There's still quite some work to be done. Is that the best way? This is a work in progress. Steerability without retraining is achievable. This notion of control token can adapt to the various surfaces for the different moment. It is at the moment at the platform level, but there is work, and I will get to this next. But this is practically is very significant. Production scale, retraining is expensive. So we have again one model, different needs, and we can do that at inference time. Something that needs work, we're not there yet, is a zero-shot generalization. So we've been training the model on a number of tasks. We can add other tasks that are a bit kind of related. It does quite well. But if we add something completely different, then we're not there. So this notion of zero-shot generalization is a big topic. And the next step, we talk about scalability. It was so much at the platform level. It works. More work to be done, of course, but at least for the use case we have, moving that control to the user so it can be like in the moment, they can share their own experience is how this conversation vision will move on. It's not as straightforward, and this is interaction. It has to work pretty fast, scalability, and also we're entering a whole area to do with the quality of the experience, safety, cost, and so on. But the capability is somewhat there to have it at scale for a great experience, work to be done. So, and good, I'm good with time. Let's move to the next one, which is agentic technology. This is us and many others moving from search to agents. An example here, look at the two screens on the right. On the left, use the user type, play some fresh indie soul I might like. The system respond with some recommendation. On the right, the same user follow up. Nice, tell me more about this artist. And the system answer, not with a new search, not with a ranked list, but with a natural response about the artist. That's a screenshot that I got, Tomish. I don't know who it is, but my colleagues told me it's very good. So, but this is part of the same conversation. So what this section is going to be focusing on is one conversation near more than, routing a query to the right API. It means deciding whether to search, recommend, engage in a dialogue, and be capable of all three. The work I will present is grounded in these two papers listed here. The first address how a system decides what the user needs. And this is going back to this notion, we're moving to trying to guess what the user wants by looking what they have done before, but really looking at understanding, oh, the user is telling me something. And the second address how it learns to hold a conversation. And this is more about when you want to start a new product, you want to develop like conversation and so on. How do you build system when you actually don't have much data? So the first question a conversation has to answer, what does this user actually want? Search result, recommendation, both, something else. At Spotify, and it's going to be also the case in other platforms, the type of query that come can be very different. For example, we've seen quite a good portion of query on Spotify. We call them exploratory, new indie release for me. Podcasts like this one, something for my commute. They're not narrow entity-specific queries. They are closer to a recommendation request, kind of expressed as a search query. Traditional search system, still mostly, but a big part of it, optimized for lexical and semantic matching, we struggle with that. What we've done is what we call parallel fusion router. The user submit a query, an LLM router interpret the intent. And this is the big change, is this interpretation comes from the query itself and can reason about it. So not just what the words mean, but what the user is actually trying to accomplish. And that's the reasoning part. Based on that, the router decides which tools to call. It could be a search API, recommendation API. We're moving into an agentic ecosystem. You can have specialized sub-agent, a combination of them. When multiple tools are needed, they run in parallel. Two key decisions: root on the query alone. Again, this has to work at scale, so not root on the user feature. So no personalization at the router level. This keeps latency low, and caching can work efficiently at scale. The personalization comes later on through the individual API, not the router. And because the calls run in parallel, the total latency is not is that of the slowest call, not the same of the sum of them. And that's really this difference, again, matters a lot for production scale. So getting the router to production requires solving a core challenge. The model needs to be capable enough to understand complex query, but small enough to run at scale. So the solution we went for is knowledge distillation using a large teacher LLM and builds a student LLM, but also with what we call rejection sampling. So we have a large teacher LLM that generates labeled routing decision. We only keep the high quality. We verify those by using an LLM judge. I will talk about this later, but it's using LLM to judge the quality of those. And we train the small student model on those. This filtering only keep high quality is very important, we found, and more or less it remove cases when the teacher was uncertain. So let's just not bring this to the student LLM. Results: lower latency, lower cost compared to the teacher, and also an increase in quality by 3%. Offline improvement are large across the board: similar artists, query, new music, broad music, podcast search. And for those kind of query, those were surfaces that was not doing great for exploratory intent. So this intent understanding is what is really changing a lot in terms of personalization, is what lets the router serve the right moment in the conversation, whether the user wants to search, discover, or something in between. This understanding is what the router is trying to figure out in real time. And again, at production scale, this has been deployed at Spotify. So so this was like the router decides whether to search or recommend. But if we go back to the example I showed earlier, the user didn't just get some result, they had a conversation. They follow up, they asked about the artist, there was a back and forth in what made the conversation experience real. And it does require an agent that can actually hold a dialogue. Now, to build such an agent, a conversational agent, you need what we call multi-turn conversation data to train on. In our cases, and it's going to be the case in many of such agentic system being developed, the data only exists if the agent has been deployed. So we have the typical call start problem. So this is where we're actually using AI for the generation of synthetic data. And we've been starting to use this already before, but this actually worked pretty well, where more or less you can try to simulate what a conversation is. And you start this by looking at one turn, unique turn conversation. The user asked this, and this was the result, and you take this as a seed. So this is a notion of building a dialogue plan. Those people that work on agentic reasoning, the word many, many years ago, the dialogue plan, actually the terminology itself is not new, but with LLM, you can really do a lot more. So before any conversation happens, the dialogue plan writes, it's an LLM that writes a plan. What the user will ask, which of the conversational capability, we have identified 5 of them. I'll go to it afterwards. The exchange need to exercise and how the dialogue should kind of unfold across turns. We have like a simulator user and a real agent, then follow it turn by turn and actually produce a full synthetic conversation. So the dialogue plan is a little bit like a template about how a conversation kind of should go. And the seed is really giving it's like, okay, this is about this topic and this is the kind of conversation that we expect. It's really scaling from 0. A single turn data set becomes the seed. And because every plan is designed around 5 conversational capability, which we have identified. So content refinement, make it more upbeat as an example. Instruction retention, only podcast under 20 minutes. Anaphora resolution, tell me more about the second one. Intent shift, actually, I want something to write down. And the separate input where it's like, okay, is it complete different things that the user wants? So the training data cover the full range of like a real conversation, a possible real conversation. So these 5 cover the range of things that can happen in a real conversation, and together they define what capable mean for a conversational agent. View this also as like it's still an option to consume, to learn about, for example, the podcast, the music, and so on. So it is still grounded in what the app is about. The taxonomy that was identified of the 5 capability turn out to matter as much for evaluation as for training. So when the agent fail, you can actually specific capability fails, and which is a much more useful question that how did the conversation got wrong? Well, it's because you didn't understand that the user only wanted the 20 minutes and so on. This was like a big thing to realize. So synthetic data, so we have those conversations that have been built according to those dialogue plans, starting with a seed, so actually real synthetic data. So it gets the agent running, but the agent can still make some mistakes. And the question is like, which mistake actually matters? Generating content, or because the agent generate conversation, the conversation plan is going to be probabilistic. The same capability might fail in one plan and succeed in another. So we all know that there's a lot of very much a kind of a nuance in responses and how agent can actually respond to things. So what we have is a self-improvement loop that we build to tell the difference between a genuine gap, okay, this went wrong, and simply a natural variation in output. And this is entering the area of automated prompt optimization. So the loop, what it does, it generates multiple plans, a seed, and score each of the 5 capability dimensions using an LLM judge. Again, we're using AI to build better recommendation, better product. And I will talk about this afterward. The variance analysis that looks at how consistent a capability fails. If it fails across most plans, then this is real structural gap. Okay, this is going nowhere. If it fails occasionally but succeeds mostly, then it's just the nature of a probabilistic system. So we just don't touch it. And to be able to differentiate this, make actually the automated, like the self-improvement loop works much better, not trying to solve everything. So for real gap, we use what is called a coding agent that automatically rewrite the prompt responsible for that capability. No manual prompt engineering, the system finds its own failure mode and correct them. And this was kind of a big breakthrough and getting much better results over a strong manual baseline, also in A/B test result. The system was launched in this April, and a self-improving agent is actually super important because conversation will become more and more capable over time. So what are the lessons learned from this work and what is next? So intent is the unifying abstraction. When the right question is what does the user want, and trying to understand this, the boundary between search and recommendation somewhat dissolved. The router does not care whether a query looks like a search or recommendation. It really cares about intent, and the right surface follow from there. So this reasoning aspect is where we spend a lot of time to get it right so it can scale. And again, there's safety issue and so on, so it's not as just straightforward. Conversational capability must be bootstrapped. So this is where you develop maybe a new type of conversation, a new agent, and so on. So we make use of synthetic data for the core sound problem, but in a while there's going to be actually real conversation, and we should make sure that this go back to train the agent, because the conversation also will evolve over time. This relates to the next one, is the capability are going to grow. So the evaluation also needs to grow. What maybe we manage to do now, the capability is going to get better or is going to change. So there's going to be like an evolution both of the capability. So we should not just say that's the way we evaluate and that's it. And the next step is capable to reliable. Agent can hold conversation. Maybe they're not the greatest. Maybe they go a little bit anywhere. Maybe if you don't want those kind of conversation, and so on. Making them reliable at scale, high quality across all user intents, and in particular, unseen one is really the open problem. So capability is somewhat there, reliability, there's still a lot of work to do. So let's move to evaluation. Building system is only half of the problem. The other one is knowing whether they work. And actually with AI, we see two things. We have to evaluate those new AI systems, but we're also using AI to evaluate them, but also to evaluate what maybe we can still call non-AI system. And this is where I will talk about LLM Judge, also called as, it's also been called at LLM as Judge. So there's a lot of interest with those LLM Judge and so on. I will focus a little bit of how they work, how we're using it at Spotify. So first, what are they? So it's using LLM, we train an LLM to evaluate output, whether it's generated by AI or something else. You can give it like a screenshot of like your screen and just say, is it good or bad, and so on. So this is an example for an LLM at LLM Judge. The two screens on the right show what it can do. A user is searching for Lady Gaga's latest album. On the left, the top result is a playlist of all hits. The judge, because of its kind of word knowledge, will flag it red. On the right, it is actually the right result. The top result is her recent album, and actually in order, green. This is a simple example, but it can do lots more. So the judge understands what the query meant and whether the results satisfy it and explain why. And this was not impossible to do, but it was hard to do before and definitely not at scale. So LLM as Judge is being used more and more, and we're also using it as a scalable evaluation layer. So it takes, in the context of search, it takes a query, but it can take, for example, a content hypothesis. It takes the output of the system, any user context, apply a rubric. Okay, I only want this bit, and if this is a good result, but this is not a so good result, actually the definition of the rubric is super important, and produce a judgment with a rationale. It is scalable, thousands of, for example, query result age at a fraction of annotation cost. It should be grounded. It is not always grounded, but because LLM have this power to understand knowledge, you can give it some ground, and I will go into this next. And it is auditable. The reasoning is visible. And that's also important when you're trying to do evaluation. So the key lesson is LLM judge works as good as the context it is given. Without grounding, maybe for some basic case, it does a good job, but reasoning from general knowledge alone can help, but in our case, it failed for personalization and also ambiguous query, where there's various ways to satisfy them. And there's likely a lot of other user cases. What we have done, we have used textual user profile. So actively you use LLM to extract a summary through the listening logs of the user and create a natural language summary of what the user general interests. And you give this as part of the rubric. You can use also behavioral signal if you have queries that maybe have to satisfy, very ambiguous. You have this data, you build a card about how this query has been satisfied and give it again to the LLM, so behavioral signal. And we have shown like a big improvement on the hardest case. The easy case, it does a good job. You don't need to help much. We've been also trying to take the Cranfield style collection where we have like a document, query, assessment, and trying to replicate this with LLM judge, and we obtain reasonable good results. And what is good with this is we can build test collection for the purpose of recommendation. Information retrieval has a much longer history of building test collection. So grounded judge is required to ensure human judgment alignment. You can see also in the literature, just don't use your judge like this. Make sure that is actually doing the right things. And there's a lot of work about the bias and all those kind of things. I will talk later on at the history of web about some of the issue using LLM as judge. What we have seen is they can actually better predict online outcomes. So we use them sometimes to decide this model and this model, which one to test and online, because we cannot maybe test hundreds of them. So it allows us to really go faster into which one to test. And this has been the area of online, offline correlation. So to finish that part, and then there will be the final remark. So LLM judge scale. They make, in our case, with personalization, it really helps a lot. Manual annotation cannot keep up, and if you add personalization on top of it, it's even more difficult. What we're seeing is they shift the question, can we annotate more, to what should we be evaluating and how do we design good rubrics? So for example, it's like, is it new? Is it relevant? So it's not just about relevance. It really can capture a lot of different dimensions of what a good recommendation is. Something is, if you're evaluating LLM and if you're evaluating a model that uses a particular LLM and use the same LLM to build your judge, there's a bit of circularity that comes into account. They will tend to kind of agree with each other and so on. You should always use a LLM judge that is super strong and hopefully better than the system. It needs to do better. It needs to be better. Otherwise, they kind of reinforce each other. If the LLM itself did mistakes, the judge is also going to do mistake if it's based on the same LLM. I talked about predicting online outcome. I think this helped making decision. What I haven't talked is it's been used more or less to look at result. But what is happening is we're moving from we're generating content, we're generating output, so it's not fixed. It's not just a rank quality and so on. So evaluating generated text, multi-turn, coherence, and so on, there's still some work to be done. And to finish, which I think should be, I'm just going to, okay. So what we build, generative recommender system that are steerable, deployable, and unified, agentic search with intent-aware routing, and the foundation for conversational multi-turn agents. What we are advancing, search and recommendation are converging into one conversation, and we're actually building some of the system to support this. Shared representation is going to be super important, and I think evaluation is going to be even more important. So just to finish, open problems, I think this open problem I'm seeing now, the technology, the frontier models are evolving, so maybe in a year time, either they're solved or there's new one, but this is where we're trying to get better at. Steerability at the user level, we can control the steerability, familiar, non-familiar, but we want this to be more live. We want like the user decide to change. You give me too many familiar before, just give me something else. So this is, early sign are there. Users can kind of be part of the conversation, refine and so on. But for this to scale reliably across the full range of user intent at production scale, there's still quite some work to do. Generalization, we're still building models that do a good job. But if we want to expand the model for something completely new, new content, new intent, new task, I think this is getting better, but we're not there. And the evaluation of generative system, LLM has just opened the path. We have toolkits, but there's still a lot of issue about using those tools, but also how to evaluate those generative systems. And I'm done. Thank you.
Thank you so much, Mounia. So I'm clapping. Anyone on the platform, you have the small icon for clapping. I'm not sure we can see that, but I'm sure others can see it. So thank you so much, Mounia, for giving this super inspiring talk. And as you're always very, very interesting and inspiring. I'm not sure if people are still getting used to the platform and don't know yet how to ask questions. So guys, don't be shy. You don't need to speak. You just need to text. And it's on the right side. There is a small icon. Click Q&A, ask questions. And while you are learning the platform, Mounia, I'm going to ask you a question actually on a topic super dear to my heart as well, which is obviously evaluation. So you said something absolutely correct, and I wish practitioners knew as well as you do how important it is that the LLM as a judge is not the same LLM, not the same capability as the one that is really fueling the agent. But this being said, so of course I understand that Spotify has trade secrets. So if you cannot answer, don't answer. Just tell me I cannot. But basically, because Spotify has so much private information about user profiles, etc. If you want to use a very strong LLM as a judge, typically they are the big ones, right? Anthropic, you name it, Google, whatever. And these big ones, they are commercial ones. They are not something that you train or you keep on-prem. So how do you do, how do you surface this potentially private information to an open, very, very strong LLM if you use them at all, right? You see you understand my question, right?
Yeah, this is a good question. It is something that is core to us. We use a lot, and we weren't able to switch because also we can see also what was happening with LLM. We may use it for something, and there's some regulation coming, and we have to switch and so on. So whatever people do, don't make sure that you can switch. So that's a recommendation, and so on. There's various things. We work with those companies. We have a contract with them. But we're also doing the first part with the generative recommender system. It's not like in-house. We take those big LLM, but then open weight and then we just train them ourselves and so on. So that is what's happening. When maybe something that is also interesting is when you use those LLM to do the judge, you can maybe use those big LLM, but you don't necessarily need to give all the information. You can do the distillation yourself and this kind of thing. What you want is a pattern. And if that user like this type of postcards and this, you can do that separately. And then it can be used and added to the world knowledge. So there's various ways and so on. One thing also we saw is that the better LLM do a much better job than the, trying to reduce cost by using like a cheaper LLM. We realized was not worth it because actually the outcome were not the best and so on. So
cool.
Yeah.
No, that's an excellent answer. It's super clear. Maybe just a small caveat to connect what you just said now to the keynote address, the excellent keynote address as well by Katrina Liggett this morning. That even if you do differential privacy, even if you do the anonymization, etc., actually somehow you will also, there is a privacy budget and somehow it will be always risky. So maybe, the solution to have things in-house is way more expensive, but the only safe solution. Anyway, let's not be too paranoid. If there are no questions so far, and we're just on time, I would just thank Mounia once more. Thank you for an excellent talk. Guys, this talk is recorded, so you'll be able to watch it later as well. Thanks, everyone, and see you in the next sessions.